the classes are small.
Compared to my sister's freshman class is 80 people, small number of people. She's got over 200 in one of the classes.
Yep. It's definitely a different vibe whenever you have 150 to 200 people in your class. Smaller classes are usually better. Can't really ask questions in a class of 200, and they don't take roll.
So what you're saying is, I could walk into a class that I'm not even in and just sit in it.
Yeah.
Isn't that what
That's my dad did for his roommates.
Isn't that what Steve Jobs did?
I don't know. He had something to do with some kind of fruit company. That's all I know.
Yeah.
All right.
Forrest Gump got into it.
We said that the LaPlace transform, we went over about 6 formulas, but I'm going to write down the 2 simplest that we went over. The LaPlace transform of 1 is 1 over s, and the LaPlace transform of t is 1 over s squared. If that is true, then the inverse Laplace transform of 1 over s is equal to 1, and the inverse Laplace transform of 1 over s squared is equal to t. Okay, so it's just going opposite, just like derivative and integral. It's just the opposite. However, what would happen if, say, we wanted to find the inverse Laplace transform of 1 over s to the 7th power? So you got to kind of think about how you would get the Laplace transform of something and get 1 over s to the 7th. All right. Our formula was what? When we take the Laplace transform of t to the n, we get n factorial over s to the n plus 1 factorial. So I could say that's equal to, and I'm going to leave a little room in front, and you'll see why in a second. All right, what number or what factorial would be on top here if our answer was if our answer was some factorial over s to the 7th, then n equals what? N equals 6. So if I was taking the Laplace transform of something and getting a s to the 7th, most of the time, if we're working just a real simple Laplace transform like t to the 6th, right? If it was t to the 6th, there'd be a 6 factorial right here. All right, but if I'm going to put a 6 factorial here, I can't just do it arbitrarily. I need to bring out a 1 over 6 factorial. So if I put a 6 factorial here, and I have a 1 over 6 factorial here, they would cancel out, and that would give me just 1 over s to the 7th, right? So I can now take the inverse Laplace transform of this and get t to the 6th. It's just that I have 1 over 6 factorial in front of it. And then 6 factorial is what? Let's see, 5 factorial is 120, 6 factorial 720. So that would be 1 over 720 t to the 6th. All right, we also went over the rule for Laplace transforms that the Laplace transform of e to the, let's see what notation, e to the at is equal to 1 over s minus a. So what if I wanted to take the inverse Laplace transform of 1 over s plus 5? Make that a 5. So that would be like 1 over s minus negative 5, right? If you have to subtract in the formula, the only way you would be able to subtract and get s plus 5 would be s minus negative 5. So that means that it would be e to the, what, negative 5t. Easy enough, right? Just going backwards. Curveballs, right? Gotta love them. So remember the other formulas that we went over. So all of those formulas have inverse Laplace transform formulas. We went over, I think it was 7 formulas. So the inverse Laplace transform of a over s squared plus a squared is equal to the sine of at. The inverse Laplace transform of s over s squared plus a squared is equal to the cosine of at. The inverse, the inverse Laplace transform of k over, not k, we're not using k on our formula sheet. Your book uses k, so I'm sorry if I use k every once in a while instead of a. A over s squared minus a squared is equal to hyperbolic sine of at. And the inverse Laplace transform of s over s squared minus a squared is equal to the hyperbolic cosine of at. All right, so let's see what these inverses would look like. Inverse Laplace transforms that will give us a sine, cosine, hyperbolic sine, or hyperbolic cosine. So let's say that we had the inverse Laplace transform of 1 over s squared plus 7. So the first thing that I would do is figure out what your a is equal to, or your k, depending on which variable you want to use. That would fit a formula that we have. Well, we have a constant here in the numerator. we have an s squared plus another constant. So for the formula to work out for sine, it has to be a over s squared plus a squared. So let's let a be equal to what? The square root of 7. If a is equal to the square root of 7, then this would be 1 over s squared plus a squared. The only other thing that we need to take this inverse Laplace transform is we would need a square root of 7 in the numerator. Because remember, it's a in the numerator and an a squared in the denominator. So if I want to put a square root of 7 in the numerator, then what would I have to put out front? 1 over the square root of 7. Right? Because square root of 7 over square root of 7 is 1. So all I'm doing is kind of playing with the numbers to get it in a form that I would want. And so now I can take the inverse Laplace transform and I would get 1 over the square root of 7 times the sine of at, which is the sine of square root of 7t. So let me find us another one of those. Maybe try. 7.2 is really long, by the way. 7.2 is got a lot of information in it. It's like a 2 class period section. Alright, so let me find you one that's not.
You want us to, like, on that one, make that a square root of 7 over 7?
It doesn't matter. I understand that you understand that in math that we do that. And usually when you get into higher maths like this, leaving it like that is okay. You say, why was I always taught to blah, blah, blah? Well, that's just the way that we teach all the other people to do it so that we can read it. But it's okay to leave it like that. So if you're OCD about it, like I am at times, it is okay to put square root of 7 over 7.
And you won't count it?
Well, I would not count off points at all. I would be happier than not.
You get bonus points.
No.
Okay, 'cause I think I know there's-
All right, so let's look at one like this. I got two actually that I want to try. All right, so the inverse Laplace transform of 5, that's a 5, not an S, over S squared plus 49. So what would your A be equal to? 7. Okay. Now, I can always factor this 5 out and put it in front. So if I do that, if I put a 5 there, then that's going to give me a 1 up here, but I don't want a 1. What do I want? If I want it to fit the formula for sine, I want it to be a 7. And so if I put a 7 here, I have to bring out a 1 over 7. So I have 5/7 in front of the inverse Laplace transform. So that's 5/7 times the sine of 7t. All right.
I hope this is like all the same file, just like 3 pages of that.
Alright, the inverse Laplace transform of 10s over s squared plus 16.
So would that be a cosine?
That's right. So that would be a cosine problem because we have an s in the numerator and an s squared plus something in the denominator. So
Would it be 1/10 cosine 40?
well, what would your a be equal to?
4.
Your a is 4, right? So we want, okay. What do we want in the numerator?
Just S.
Just s. So I don't need to, all I need to do in the numerator to work this out is to bring the 10 out in front. If I bring the 10 out in front, like this, then that'll be 10 times the cosine of what? 4t. Because your a is 4. So it is important that we always figure out what our a is equal to.
Couldn't you have also, if you really wanted to, convert that to hyperbolic cosine? I guess.
Because of subtraction on the bottom.
Yeah, we have let me see, where's hyperbolic cosine? Yeah, we have a subtraction there, so we can't just say minus negative. We can't say minus negative because you can't take the square root of negative 16 and get a real number. Alright, I want to see if you can figure this one out, and then we'll actually do one that requires you to think. Let's see, 4 over s plus 6 over s to the 5th minus 1 over s plus 8. Of course, you want to take the inverse Laplace transform of each term. Bless you. Already got it, huh? Alright, so the inverse Laplace transform of 1 over s is what? 1. So that would be what? Just 4. And then the inverse Laplace transform of 1 over s to the 5th you have to think, or 6 over s to the 5th, you have to think, okay, so n equals 4. So I would want a 4 factorial in the numerator. So you need to bring out, and you have a 6, so bring the 6 out, and then bring out a 1 over 4 factorial. So you'd have 6 over 4 factorial, which, yes, can be simplified, and should be. T to the 4th, and then minus, and then this last one, that's the easiest one, e to the negative 8t. Right?
Oh, I did minus 1 over square root of 8 sine square root of 8 too. But
It's not s squared though, so. Alright, so 4 factorial is 24. So it's going to be 6 over 24. So that's 1/4. Okay. Alright. Let's look at this one. The inverse Laplace transform of negative 2s plus 6 over s squared plus 4. Alright, we don't have a rule that has an s in the numerator plus a constant or minus a constant. So what we have to do is we need to break this up using first term-wise division. So this would be the inverse Laplace transform of negative 2s over s squared plus 4 plus the inverse Laplace transform of 6 over s squared plus 4. So first term over the denominator plus the second term over the denominator. Alright, now the first one I have an s in the numerator. There's a negative 2 in front, which can be factored out. And if you bring the negative 2 out, you'd have s over s squared plus 4. And that would fit the formula for cosine, right? So that would be negative 2 times cosine of, what's the a? 2, because that's a squared. So that would be 2t. And then this next one, this is going to be sine. We have a 6 in the numerator, and what do we need in the numerator? A 2. So you can put a 2 up there. That's fine. It's just you would bring the 6 out and then bring a 1/2 out as well. So you'd have 6 divided by 2. Right? So you'd have 6 divided by 2, and that would give you a 2 right there.
what would we bring that 1/2 out?
Because if we want a 2 in the numerator, because a equals 2 from the denominator, to fit the formula we want the same a in the numerator. But if we put a 2 here, we have to bring out the reciprocal. We have to bring out the 1/2. We've already brought out the 6. So 6 divided by 2 is 3. And then it is sine of 2t. Alright, you try this one. the inverse Laplace transform of s plus 1 over s squared plus 2. Alright, I'll start breaking it up. Hopefully you already have as well. Alright, so for both of these, your A is equal to the square root of 2. The first part, when we split it up, the first inverse Laplace transform is a cosine, because it has s squared in the an s in the numerator. And then the second one is a sine, because we have a constant in the numerator and we have an s squared in the denominator plus something. But for both of them, a equals 2. And for the sine, that means that we would want a square root of 2 in the numerator, so it would fit the formula. And so if we put that in the numerator, we have to bring out a 1 over square root of 2, which is the square root of 1/2, by the way. Think about it. And so that's on the outside. So there's your answer. So 1 plus 1 does equal 2. Alright. Now, what if we had the inverse Laplace transform of s squared plus 6s plus 9 over s minus 1 times s minus 2 times s plus 4. Yeah, you would not want to multiply the denominator out. You would get an s cubed term, which then does not fit any of our formulas. But I do need to figure out some way to rewrite that. Linear factors in the denominator. Does not ring a bell. Okay. We do that little AB stuff. I don't think that will help you because of the method that we have to use to split that up. It's called partial fractions. So A over S minus 1, these are distinct linear factors, so we do just put A over the first one plus B over the second one plus C over the third one. Then we're going to take and multiply through by the common denominator. Alright, and so when I do that, I'll have s squared plus 6s plus 9 equals a times s minus 2 times s plus 4 plus b times s minus 1 times s plus 4 plus c times s minus 1 times s minus 2. Alright, now it might be worth, when we have distinct linear factors, or we don't have any repeated factors of any type, it is worth using the shortcut method to figure out A, B, and C. Now, normally, I would multiply out everything on the right side of the equation, and then I would group like terms and set up a system of equations and solve for A, B, and C. However, since there's nothing repeated, the easiest way to solve for A, B, and C is by using the shortcut of picking a number and letting S equal that number, but picking it in a way such that the B and the C term, or the A and the B term, or the A and the C term both turn into 0. If I do that, then this will be, I can solve this pretty quick. So I don't know that I've showed you the shortcut method. Maybe I did once or twice, but normally I don't use this method because it doesn't always work. It doesn't work if we have repeated factors. So I'm going to say for S equals, let's see, if I let S equal to positive 1, then what would the left side of my equation be? I would have 1 squared plus 6 times 1 plus 9 equals, and then let S equal 1 here and S equal 1 here. So that means I would have negative 1 times 5 times A. Negative 1 times 5 is negative 5, so that would be negative 5A. Now look what happens whenever I let S equal 1 here. This in the parentheses becomes what? 0. So then that times anything is 0, times B is 0. So the B term would go away. Also here, if I let S equal 1, 0 times anything is 0, times C is 0. Okay? So by choosing 1, and the reason I did that is because it would make the B and C terms go to 0, I can now easily solve for A. So that's 1 plus 6 plus 9, so that's 16 equals negative 5A, or A equals negative 16 over 5. Now, what should I choose for S next? How about 2? Okay, so if I let S equal 2, I'm going to have 2 squared plus 6 times 2 plus 9 equals, now what happens when I let S equal 2 with the A term? This parentheses goes to 0, so that whole term goes to 0. Then I'm going to let it equal 2 in the next term, in the B term. So that's going to be 2 minus 1 is 1 times 2 plus 4 is 6. So that's going to be 6B. And then my C term, because if I let s equal 2 in the last parentheses, last factor here, that term goes to 0, it just goes away. So I have 4 plus 12 plus 9. So that's going to be what? 25, right? So 25 equals 6b. So b equals 25 over 6. Now, what's the next logical number for me to let s equal? -4. That's right. Because that would make my a term and my b term both go to 0 and go away. So I have -4 squared plus 6 times -4 plus 9 equals, a and b go away, and that's going to leave me with -5 times -6 in front of the c. So that would be -5 times -6 is 30. C. So that's 16 minus 24 plus 9. That's 25 minus 24. So that's 1 equals 30c. So c equals 1 over 30. Alright, so I did that so that I can take and make my inverse Laplace transform -16 over 5 over s minus 1 plus 25 over 6 over s minus 2 plus 1 over 30 over s plus 4. Then I take the inverse Laplace transform of each of those separately and factor out the constant for each of those. Take the constant and move it to the front. And all three of those inverse Laplace transforms are in the form of what? E. E to the AT, right? So this is going to be equal to -16 over 5 e to the 1t, right? Because it's s minus a is the formula, plus 25 over 6 e to the 2t plus 1 over 30 e to the -4t. Alright. I'm going to get you to try number 24. Looks like on number 24, using that shortcut method would probably, for partial fractions, would be the best way to do it, even though you don't have to. I don't know about you, I'd rather do it the long way every time. Not really. And all those are S's, there are no 5s. there were only a way on the calculators.
Sure there is, we just don't know.
Probably tell us after we do this.
Well, of course there's a way on the calculators. Calculators do anything. Just don't tell Mac. Because I want to see him sweat. Of course, he may just skip them all, so whatever. C stands for degree, right? Or is that D?
C's make degrees.
C's make degrees, that's right.
Unless it's your last semester of school and then D's make degrees. You can go transfer.
I think I would love to take a class that was so hard that I'd make a D in it. Just to see what it was like, how hard it would actually have to be. Maybe if I was taking an advanced math class taught in German or something like that.
Or you just take like really, really advanced, like some random subject that you don't know about.
Yeah. Like, maybe a creative writing class. I bet I'd make a D in that.
You can't be creative.
Guarantee.
I can't write.
I'm not a very good reader.
I'm dyslexic, but actually reading was my best score in ACT.
Wow.
I made a 31 in that section, I think.
I can only hope that my daughter loves to read more than I do. And judging how she did last night when I made her read a book to me, probably won't. What's up with this cup? Even though I wasn't reading like she's reading when I didn't go to kindergarten, but man, this book she's reading, any book that has like 40 words on a page and words like amazing and just bigger words than a 5 to 6 year old should be reading. I guess maybe I'm kind of not giving them enough credit, but yeah, back in the old day when we used to read by candlelight, we all had to learn Braille because we didn't have light all the time.
Well, no, like even when I was in kindergarten and stuff, like they didn't use that.
This has got to be a trick coffee cup because every time I take a drink, coffee's coming out. Well, I mean, coffee should come out, but it's also coming out, yeah. Alright. I'm going to start working. I'm sure you're probably done by now. Think about not using the shortcut method on this. It would actually take a while. Because you'd have to multiply out those three binomials. Every time we'd have to multiply out the three.
And you have 4 equations, 4 unknowns.
And there is a way to get around and use that shortcut method with repeated. But I know I've not showed it to you. The workaround isn't too hard. I might show you, depending on how hard you work on the partial fractions. And you might be able to figure it out. The way to get around is to punch in your calculator, right? Wolfram alpha. If you're time you use Wolfram Alpha, a baby kitten is kicked.
Wait, what?
I know, right? So you don't need to use those shortcuts on the internet because we all love baby kittens. Yeah, a baby kitten is kicked every time you use Wolfram Alpha. Yeah, it's kicked with a feather pillow or feather shoe. How about that?
Oh, okay. I'm good.
I thought you said cooked or something like that. I was like, that's why I was looking at you weird.
Calm down, man. Like Tyler.
Calm down, it's not lunch yet.
What are you, Chinese?
All right, so, actually, it's really, really easy. You just need to pick the right numbers. So for s equals 1, going to have 1 squared plus 1, so that's 2. And then 1 makes that 0. It makes a, c, and d 0. So 1 times 2 times negative 1, so that's negative 2. So b equals negative 1. And for s equals negative 1. Negative 1 squared is 1, plus 1 is 2. A0, B0, D0. So negative 1 times negative 2 times negative 3. So negative 6c. So c equals negative 1/3. For s equal to 2. That'll be 4 plus 1 is 5 equals 2 times 1 times 3. So that's 6, right? So get d equals 5/6. For last one is 0, right? Yeah, I do know how we get those. I'm sure you know how we get those numbers, but we set each factor equal to 0. Each one of our factors. So for 0, that's going to make b, c, and d 0. I have 1 equals negative 1 times 1 times negative 2. So it's going to be 2a. So a equals 1/2. Alright, so I have the inverse Laplace transform of 1/2 over s plus negative 1 over s minus 1 plus negative 1/3, and you can make those minus and then make the number in the numerator positive if it makes you happier. Let's see, c was negative 1/3, and then d is 5/6. Alright, so that's going to be equal to 1/2 minus e to the what? 1t minus 1/3 e to the negative t plus 5/6 e to the 2t.
Why'd you put the negative on the e, not the 1.5? Or is it 1/2 minus e?
Yeah, that's mine. Because the first term is the inverse Laplace transform of 1 over s. So that's just 1. And then you have a 1/2 there. I mean, you see how these answers are kinda looking like some of the answers for the differential equations? That's because we can use these to help solve the differential equations, and then we're gonna get answers like we normally get. I'm gonna do a partial fractions, I guess, that has a quadratic in it, just to remind you how to do that. So let's say I had the inverse Laplace transform of 1 over s to the 4th minus 9. Well, the first thing that I have to do is factor that thing. And so s to the 4th minus 9 is s squared plus 3 minus 3. Can that be further factored?
Can you go out on a limb and say yes?
What do you think you would do?
Would you go ahead and split it up?
Could you say that's s minus the square root of 3 and s plus the square root of 3? It is a difference of squares, but this isn't the typical square. Like, it's not a perfect square. That's how you would have to break that up if you wanted to completely factor it. And you can't break up a sum. You can only do that with differences. I'm curious to see if the book would even do that, because the rule for partial fractions is for quadratics is that it's an irreducible quadratic factor, and s squared minus 9 in my mind technically is not irreducible. It can be reduced to these two linear factors. Those are still linear factors. So I am going to work the problem like this, and it's an even problem, so I think I can look up the answer, and I'll do that after we finish it and see if they are as smart as we are, even though I'm sure they are smarter than we are, but smart is all relative, that term itself. Alright, so that's going to be equal to, now when we have a irreducible quadratic, remember we have to use two variables. It'll be AS plus B. You know, before we would have AX plus B, but we're using S. So that's over S squared plus 3 plus C over S minus square root of 3 plus D over S plus square root of 3. Alright, so if I go through and multiply everything by that common denominator, then we will have 1 equals AS plus B times S minus square root of 3 times S plus square root of 3 plus c times s squared plus 3 times s plus square root of 3 plus d times s squared plus 3 times s minus square root of 3.
We're gonna have to work this one out for one month.
Probably. I think it can be done without. However, it will be kind of tricky. So let's just work it out the long way just for old time's sake. All right, remember s minus 3 times s plus 3 is s squared minus 3. And I say that's important because if I'll just multiply that times as plus b. So that'll be as cubed minus 3as plus b s squared minus 3b. Now these are the tricky ones here. I'm gonna put the terms above it. So that's gonna be s cubed. Then we're gonna have plus square root of 3s squared plus 3s plus 3 square roots of 3. Alright, so what is that going to give us? That's going to give us plus cs cubed plus square root of 3cs squared plus 3cs plus 3 square root of 3c. And then here we're going to have something very similar. It's going to be s cubed minus square root of 3s squared plus 3s and then minus 3 square root of 3. So that's going to be plus ds cubed minus square root of 3 ds squared plus 3 ds minus 3 square roots of 3d. Alright, so a plus c plus d times s cubed. Now look for all the s squared terms, plus b plus square root of 3c minus square root of 3d times s squared. Now look for all the s terms. And put plus negative 3a plus 3c plus 3d times, wait, yeah, that's right, 3d times s. And now the constant terms, minus 3b plus 3 square root of 3c minus 3 square root of 3d. Alright. So a plus c plus d equals 0. B plus square root of 3c minus square root of 3d equals 0. Negative 3a plus 3c plus 3d equals 0. And negative 3b plus 3 square roots of 3c minus 3 square roots of 3d equals 1. So I have two equations that have b, c, and d, and I have two equations that have a, c, and d. So linear algebra, people, how do I solve these 4 equations and 4 unknowns? You could do it in your calculator pretty easily by either using the inverse or any other reduced row echelon form. You'd have to type in your matrix. You have to type it in all correctly, but we don't have that pleasure of I'm not going to use technology. Caveman, working by the fire, burning my eyebrows as I work the problem on a stone tablet.
What are you using carving to the stone?
An old saber-tooth tiger tooth. Pretty sharp. I had to, no, not Diego's friend. What's Diego's friend's name?
Which one? Sid.
Sid? I thought he had this little tiger friend.
Oh, the girl tiger, the white one.
Alright, so
She was a pirate.
let's see. We need to be creative.
Can you take, you can take that first one, that a plus c plus d,
Mm-hmm.
the negative 3a plus 3c plus 3d.
So what you're saying is take this one, say it times 3, and add it to this.
I was going to say, say it times negative 3 and add to that.
To get rid... you're a little smarter than I thought you were. Just kidding. Why would you do that, though?
Cancel out the c and the d.
Yeah, because the way I was doing it, I was only going to cancel 1 out. He saw that if I say it times negative 3, it cancels 2 out. Now, maybe that'll help me, maybe it won't. Let's see. I think that'll allow us to solve for a, right? So that'll be negative 3a minus 3c minus 3d equals 0. And so that cancels out, negative 6a equals 0, so a equals 0. Okay?
So now we know that c is equal to negative d.
We do know that, don't we? Because if you plug it back in the first equation, you'd have c plus d equals 0, so c is equal to negative d. So if that is true, we can take the other two equations and plug in negative d for c. And so I'd have b, if that's a negative d, that's going to be a negative square root of 3. Everybody see that? And what's negative square root of 3 and negative square root of 3? Right, that's negative square root of 3d, negative square root of 3d, that's negative 2 square root of 3d. And I'm going to do the same thing here. I'm going to plug in a negative d.
I
So,
just thought of something though.
what did you think?
Take that first formula and times it by negative 3 again and add it to the fourth. That second one, that b plus square root of 3c minus square root of 3d, times that by negative 3. Well, no. Well, yeah, it would, because it'd be negative 6b equals 1.
Yeah, there's a lot of different ways we can do this. So if I follow your first train of thought, try to focus in on that, then looks like I need to multiply the top times what? 3. If I multiply this times 3, that would be 3b minus 6 square root of 3d equals 0. And so that's negative 12 square root of 3d equals 1. So I get d equals negative 1 over 12 square roots of 3. Or you could write that as negative square root of 3 over 36. Either way is fine. If I know that, then I know C equals positive 1 over 12 square root of 3, or square root of 3 over 36. And what about B? If I plug that in for C and D, would they cancel out? Let's say I took it doesn't matter which equation I use. If I use this equation and I plugged in that, that would give me negative 1 over 12. And then if I plugged in, let's see, I'm sorry, that was D. So if I plugged it in here, that would give me positive 1 over 12. And then if I plug that in here, that would be negative. No, they're both positive. Okay. Let me go ahead and do that then. So it's a square root of 3 times square root of 3 over 36 minus square root of 3 times negative square root of 3 over 36 equals 0. So go ahead and make those fractions. That'll be b plus, that's 3 over 36, or 1/12, plus 1/12. So that's 2/12 or 1/6. So I get b equals negative 1/6. Alright, so I've solved for A. We got that as 0. B is negative 1/6. C is, I don't care how you write it. It looks prettier to me as the square root of 3 over 36, but you know, just whatever is best for you. So I'm going to take this part because this is what I need. Copy that. And put it right here. Erase that. So that's going to equal, A was 0, B was, that's negative 1/6 over s squared plus 3 plus square root of 3 over 36 over s minus square root of 3. I just find it funny because, yeah, it's crazy. All right, so if I take the inverse Laplace transform of all that, that fits the sine formula. I just have a, I have to, if I put a, let's see, A equals square root of 3, so I need a square root of 3 up here. So I have to bring out a 1 over square root of 3. So that's negative 1/6 times 1 over square root of 3 times sine of square root of 3t plus square root of 3 over 36 e to the square root of 3t plus, or actually going to be minus square root of 3 over 36 e to the negative square root of 3t. So I'll just write this as negative square root of 3 over 18 sine square root of 3t. I mean, I'm pretty sure if you factor out a square root of 3 over 6, it'll make it look better. But there we go.